So if there are other ones that we want to go over, I'm happy to do that. But 7, 8, and 10 seem to be the ones that people miss the most. So if I'm looking for a counter example, really what I want is a counter conclusion. I want an animal that's a panther, but I want it to live somewhere other than the forest, right? So it's definitely not a monkey because a panther is not going to live in a monkey. What I'm looking for is a counter conclusion. I want a different ending to my sentence. Some people do argue that a panther could live in an aquarium. Maybe. There's no counterexample. Well, that's possible. But there's a fourth answer down here. It lives in a zoo. So what's a better answer? A panther could live in a zoo or a panther could live in an aquarium? Probably in a zoo. Every once in a while, I get a student that's like, well, maybe the whole aquarium is talking about the Amazon and they could have a panther in there because they live in the Amazon. I'm like, okay, I could give you that. Maybe they could live in an aquarium, but I think more panthers live in zoos than aquariums. So again, maybe the best wrong answer, right? I'll give you half credit on that, but the real answer is a zoo. And when we're doing counter examples, we want to keep the conclusion or keep the hypothesis and change the conclusion. Okay, questions on that? Number 8 is usually the one that most people have a hard time with, and it's just a weird worded question. When you add a multiple of 6 and a multiple of 9, that's my hypothesis. So I need that to be true. Then the sum will be a multiple of 6. This is my conclusion. This is what needs to change. Okay? So I still need a true statement, but I need the ending to be different than this ending. So we've got to compare. Is 12 a multiple of 6? Yeah, 6 times 2 is 12. Is 27 a multiple of 9? Yeah, 9 times 3 is 27. So all of that works out. I've got a hypothesis that's true. Now I'm looking at the 39. 12 plus 27 is 39. So this is a true statement. And 39 is not a multiple of 6. So this is a true statement. Yes, it is a counterexample because 39 is not a multiple of 6. I changed the conclusion.
It took me like 6 minutes rereading that question over and over again just so that I was ready and I was first and
Absolutely. This one takes a long time. This is definitely the toughest question on of the 10, right? So I'm super proud of everybody who got that right. And a lot of people struggled with it and did. The wording is crazy. Sometimes in geometry, the wording is going to be super confusing. Push through, okay? Break it into as many small parts as you need to, and then it'll ultimately make sense. Or if it's just a crazy, stupid question, give your best guess and move it right along and don't stress yourself out, right? It's just not worth that much level of stress. So here, another counterexample question, counter conclusion. So I want to change the conclusion. Is there another number that if I substitute it in here will give you 169? Is there another answer to the square root of x, or x squared is 169? What's the best answer here? Negative 13. And exactly. So a negative times a negative makes a positive. The square root of any perfect square is going to be plus or minus whatever that square root is, right? Did you guys notice that when you submitted your first attempt that there was like feedback for you that would help you in the second attempt? Did anybody notice that? Hopefully.
Yeah.
Okay. So almost always the way I have these green puzzle pieces set up is if I can give you feedback on that type of question, I will. And on your second attempt, hopefully that feedback helps you get a better grade, a better score. Okay. Any questions on that puzzle piece? I'm looking at the chat for a second. All right. So let's go into today's lesson. And I think we're going to start in that digital notebook. Yep, digital notebook. So if you want to go to your digital notebook, I am going to go to mine. So we sorted yesterday, converse, inverse, and contrapositive. Everybody seems like they've got that down. There is some IXL practice on that. So that's kind of your homework for the weekend and for Monday. We started biconditionals yesterday. So biconditionals have to be able to be read and be true both directions, front ways and back ways. So if a shape is a triangle, then it has three sides. If a shape has three sides, then it's a triangle. If both of those are true, and usually these are definitions, then the biconditional is true. If only one of them is true, then you can't write the biconditional. Okay. So we did one example yesterday in a very short time frame. If a person lives in Virginia Beach, then they live in Virginia. That is true. If they live in Virginia, then they live in Virginia Beach. That is false. So our biconditional up here with the if and only if in the middle of the sentence is going to be false. I did this one down here. I want you to check yours to see if you agree. I'm going to see if I can come down here. Make it a little bigger, easier for us to see. If two line segments are congruent, so I took the beginning of the sentence, the hypothesis, and put it behind an if. Then I took the end of the sentence, the conclusion, and put it behind the comma then. Is this sentence true or false? Two line segments are congruent, then they are of equal length. Remember, congruent means they're exactly the same in every way. So is that true or is that false?
True.
It is true. This is a definition. Congruent line segments are always the same length, right? So if I turn that around and I change the order and write the converse, if they are of equal length, then two line segments are congruent. Is that true or false?
True.
True. This is a definition of congruent line segments. So definitions are almost always biconditionals. So if the conditional statement is true and the converse is true, then the biconditional is also true. And remember, when you're writing the biconditionals, and you're going to have to do that today, the if comes off the beginning and the then comes out of the middle, and we put in if and only if. That if and only if phrase is what determines whether it's a biconditional or not. Okay. What I'd like for you to do now is, while I do attendance, I'd like you to write just a brief summary of what you need to know about biconditionals. You decide what's important for you to know about biconditionals and write it here. Maybe 2 or 3 things. I am going to go look at that this afternoon. So write something there. I'm going to go do the attendance and then I'll be right back. Questions? Anybody who started it? Any questions on any of them? No, I know a handful of you have started it. Usually question 5 has some questions. So remember, a foot has 12 inches. If a table is 36 inches tall, then it is 3 feet. Write the converse. So if I write that converse, I've got to change the order of those sentences, right? The table is 3 feet, needs to come at the beginning. So if a table is 3 feet tall, if a table is not 3 feet tall, I'm not trying to do the contrapositive, so I can't have the not. If a table is 3 feet tall, that looks like it works. And then if it is 36 inches, that's not going to work because that's the P, right? So I wanted to start with the Q. Can't be B, can't be D. So as you go through your homework, this is what you're going to do. The table is 36 inches tall. That has to go at the end. And then the table is 36 inches tall. That goes at the end. So then I'm writing the biconditional. With the biconditional, that if and only if has to go in the middle. The if and only if can't be at the beginning. Okay. So as you go through these, you're going to want to cross off all of the nonsense. As you get to an answer choice that doesn't work, cross it off. This lesson is all about slash the trash and then see what's left over. Okay. Anybody else who started it? I'm looking in the chat. We have any questions? No? All right. Take a mental note. This one should be 100% because I've just shown you how to do it. If you need to screen capture it, screen capture it. If you're not on the quiz, okay? This is homework part 2. So finish your IXLs, finish these 9 questions. And then homework part 3, hopefully we're going to finish right now. So navigate over and I'll give you a minute to get to the interactive notebook. I'm on page 11. So you did page 10. Now we're on page 11. Does everybody have access to their notebook? We all went silent. Okay. Remember, there is a video up here, right? There are 3 logic laws. These we don't talk about true and false. They're more valid and not valid. So with all of the stuff we've learned so far, we've been talking about, is it true? Is it false? Can I rewrite it in the converse, inverse, or contrapositive pattern? These 3 logic laws have to be valid. In order to be valid, they have to follow a pattern. They can be valid, but not true. So be careful about that. This is where it gets a little tricky. Law of detachment, when you literally detach something, you separate it, right? So the word detachment clues you in to I have a compound sentence, if P, then Q. Then you're going to write 2 simple sentences, P period, therefore Q period. In detachment, we're going to take a conditional sentence and break it into its 2 parts. The hypothesis is going to become a simple sentence. The conclusion is going to become a simple sentence, okay? Then we've got contrapositive. We already know that contrapositive means to switch and negate, right? So I take this compound sentence, P if P, then Q, and I separate it again into 2 statements, but my first simple sentence is the negation of the conclusion. So not Q. And then my second simple sentence is the negation of P, not P. So I've got detachment where I take one big sentence and I separate it into 2 simple sentences. I've got contrapositive where I separate it into 2 sentences, but I switch the order and negate them, okay? And then syllogism is the crazy one, okay? Syllogism is going to have 3 sets of compound sentences, and it's going to have 3 different clauses. So we've got a P clause, that's the hypothesis. We've got a Q clause, that's the conclusion. And then we've got a new conclusion over here. Or maybe the hypotheses match up. And we've got a hypothesis and a conclusion and a new hypothesis. But basically here we've got 3 distinct clauses, and they're rewritten in three different compound sentences. So law of detachment, law of contrapositive, we've got simple sentences. Law of syllogism, and that's a crazy word, it's pronounced syllogism, has three compound sentences. Okay. We'll come back to this example, because I feel like at this point we probably have more in our heads than we can think about. Go to slide 12 with me. Look at what the similarities are and what the differences are. So first, describe what you see. Put in a couple of sentences here. Describe what you see. So maybe you write if, then, case, to, if, period, and period. Okay. That's what I would write. That makes sense to me. I've got one compound sentence, an if-then sentence, and then break it apart into an if and then. Here, with contrapositive, that same if and then sentence, and I break it into not, to, period, and not, he, period. It's a little bit different. So you write whatever makes sense to you, and you might have to revisit this at some point. Because it might not make sense right now, but it will eventually.
Probably going to go over through 17 next week.
Well, I'm going to try to do some of them right now. So we've still got about 10 minutes in class, and I'm going to try to get to that right now. And then we'll revisit it next week. With syllogism, you've got three compound sentences. And one clause repeats. Okay. So write in what you see that's similar. Next week, when we come back on Tuesday, after we talk about 13, 14, 15, and you've watched the video, we'll talk about similarities and differences. Right now, I just want you to have the P and Q, the if-then breaks into if and then. And then the if-then, the conditional statement breaks into not Q and not P. The order changes and we insert the nots for contrapositive. And then syllogism, we've got three compound sentences and one clause repeats somewhere. And I feel like it's easier to go look at some examples. Does everybody have these three things?
Yeah, I'm ready right now. So give me 1 second.
Okay. And kind of talk yourself through it out loud. Detachment means you separate them. Contrapositive means you separate them and negate them. And the law of syllogism has three compound sentences, and something is going to repeat. Either the hypothesis is going to repeat and go to the conclusion, or the conclusion is going to go to the hypothesis. But they have to repeat on a diagonal, and we'll see that pattern in a few minutes. Give you about 1 or 2 more minutes to finish this. If you're already finished, you can go on to slide 13 and see if you can do the pattern for example number 2.
I'm still confused on how this works.
Okay, so we're going to take a conditional statement. We're going to start with a PQ. So if I'm a mom, then I have children. And we'd break that apart. So the example would be, I am a mom, period. I have children, period. You make those two, the hypothesis and the conclusion, into sentences. If I take that same thing with law of contrapositive, if I'm a mom, then I have children, and I turn it around and negate it, if I don't have children, then I'm not a mom. If we've got the law of syllogism, we could say, if I'm a mom, then I have children. If I have children, then I am very tired. So the children are here and the children are here. If I'm a mom, then I am very tired. I don't need that children stuff in there at the beginning and the end. So it's going to make more sense when we put actual words to it and not symbols. So if you just kind of trust me and do these 3 things, we'll come back once it makes more sense and do the purple and the pink. Okay. Is everybody ready to go to slide 13, even if you're unsure about what I'm talking about right now? Lots of people are going to be unsure, and that's okay. That's where you should be.
So when we write the one similarity and one difference, we want to use the symbols?
Sure, but let's go back to the similarity and differences on Tuesday. You don't need to do those right now, unless you want to. But I think it'll make more sense to do the similarity and difference on Tuesday, after we kind of work through a couple. So let's go to 13 and see what it actually looks like. So law of detachment, we're going to separate, right? If Mark saves $30, then he can buy a new video game. Mark saves $30. Therefore, Mark can buy a new video game. All we did was we took the P, we separated it out, made its own sentence. And we took the Q and we separated it out and made its own sentence with the therefore, the 3 dots, right? So we're kind of thinking like a lawyer. I'm just separating those 2 things. Detachment means to separate. So this is a valid statement, a valid pattern, but it is a false thing because Mark could buy something else other than his video game. So what I want you to see is even though this is a valid pattern, it might not be true. So those are 2 separate questions. And with really smart students, that's where we start getting into trouble when we do these. When we start looking at the logic laws, you want to see if they're true or not. And I want to know whether they follow the pattern or not. So if a quadrilateral is a rhombus, that's my P, right? So you can underline that. That's my P. Then it is a parallelogram. Bold that. That's the Q. So if I separate that out, I'm just going to do P, period, and Q, period. Right?
I had a good question. So, like, I just wanted one question, not for the law of detachment, but the law of, I don't know how to pronounce it.
Syllogism?
Yeah, that. Sorry. Will it ever be in a case where the pair will be like on the same side?
That's where it's false. That's where it's not valid. And we're going to see that in a minute. So I'm really glad, Miriam, you asked that question.
Yeah, because there was just something that I was like, oh, this is how this would go. But then
right.
I was thinking, like, if ever a test or someone comes up, will they ever be on the same side?
Yeah, we're going to see that in a minute. And that's where they're not valid. Okay. So if I separate it P first, then Q first, then it's valid. Here, if I switch it around, I cannot put a quadrilateral is a parallelogram and then a quadrilateral is a rhombus. The QP does not work, only the P and then Q. So that's part of what this is, right? We can't switch it around. It's got to be P first and then Q first. So law of detachment here, what's my conclusion? This is my non-example, right? Miranda runs 4 laps around the track. Then she ran a mile. They're trying to say that if she ran a mile, then she ran 4 laps around the track. This way is not valid. And in this yellow box, I want you to tell yourself what's different. So why does this not work? You can't go Q to P. Exclamation point. Bold that. Okay. You cannot go from Q to P. The pattern is P to Q, not Q to P. You've got to start with the hypothesis and then you can give the conclusion. You can't go backwards from the conclusion to the hypothesis, right? Because we just saw the biconditionals don't always work. Of all of those true-false statements that we had the other day, only 4 of them could be written QP. So this is not a valid pattern. Okay. So slide 12 shows us how we can do the law of detachment. And slide 13 says how we can do it. And slide 14 is the non-example, how we cannot do it. Okay. We've got about 3 minutes. I'm going to try to do contrapositive, and then we'll leave the law of syllogism until Tuesday. So contrapositive is exactly the same. We're going to separate the compound sentence into 2 simple sentences, but the pattern is a little bit different. We're going to start not Q and then not P. So a shape is a square, then it's a rectangle. The shape is not a rectangle. We've taken the Q and made it not. And then we take the shape is not a square. We take the P and negate it. So if you live in Texas, is the hypothesis. Then you live in the United States is the conclusion. So I take this conclusion and make it negative. James does not live in the United States. That not is the most important part, right? Then the conclusion is James does not live in Texas. And that not is the most important part. We've still separated them. One compound sentence turns into 2 simple sentences, but this pattern is the not Q and the not P. I can't write it the other way around. If it starts P, it has to be positive, and if it starts Q, it has to be negative. Okay, and that's just the thing you have to memorize with this. Last slide. What's the difference between this pattern and this pattern? What did we do wrong? The valid pattern is not Q, not P, and this goes not P, and they're trying to get you to put not Q. Okay, so this one, the pattern must go not Q, period, not P, period. Okay, it is 8:50. It is time for us to go. You guys all have a fantastic weekend. I'll send you a reminder of what your homework is, but it's IXL, the green puzzle piece, and the notebook.
Bye.
That was a big class today. Have a great weekend, guys.
Have a good day. Bye.
Okay, see ya.